called optimization. And when we want to optimize something, we want to make it the best, right? So if we're trying to optimize our profit, what are we trying to do? We want to make the most money. If we want to optimize our cost of materials, we would want to make it low, right? So we're going to be talking about like maximum and minimum, okay? Now, these are all going to deal with linear equations, which is why we call it linear programming, all right? But these are the steps that you're going to take. So you remember that word problem that we did at the very end of Thursday's notes about like vitamin A, vitamin C, all of that stuff? Okay, so that's kind of something that we're going to deal with, but there's going to be an extra piece of information. And that extra piece of information is going to be our objective quantity. What are we trying to optimize? So we're looking for either a maximum or a minimum. Okay? And we're going to write an equation involving x and y. All right? Now, just like last week, we're going to set up some inequalities. We're going to graph those inequalities. We're going to find the vertex points of those inequalities. This is all what we did last week. What we're going to do with those vertex points is then go back to our objective quantity, what we're trying to maximize or minimize, and we're going to plug those points in. Which one makes it the biggest, or which coordinate makes it the smallest? And then we can make a decision about maximum or minimum. Okay? So, in your first example, I've already graphed it for you, right? Just trying to save us some time today. Okay? Find the minimum and maximum of z equals 3x minus 2y. This is our objective quantity. Okay? So in this problem, we're just going to practice very basic. I'm giving you the objective quantity. I gave you the inequalities. And even for this morning, I graphed this one for you. Okay? On your checklist, what do we do after we graph? Find vertex points. Please take 2 minutes at your pod to determine what our vertex points are. How many are there? 4. There are 4. Mary Kate, give me one of your vertex points.
0, 0.
Aha, 0, 0. That's where x equals 0 and y equals 0 are intersecting. Okay? Awesome. Austin, give me another one.
0, 2.
0, 2. That is where x plus 2y equals 4 is intersecting x equals 0. Okay? Let's see. Chelsea, give me another one.
1, 0.
1, 0. That is where x minus y equals 1 is intersecting y equals 0. And then we have one more. We have this intersection point. Kaya, what is this intersection point? 2, 1. How many of you used algebra to get 2, 1? How many of you checked it into both equations to make sure it was really 2, 1? That is not enough hands. What did I just tell you about your quiz? Are all of our numbers nice? No. Does 2 plus 2 plus 1, or excuse me, 2 plus 2 times 1, what does it equal?
4.
Good. 2 minus 1 equals? Okay, so that is fine. But come on, if you're not going to do the algebra, at least plug it in. Okay, laziness did not go well for you on the quiz. Okay, with these vertex points, you are now going to plug them into your objective quantity. So our objective quantity was like z equals something? Z equals 3x plus 2y. So z equals 3x plus 2y. Z equals 0 for that coordinate. Z equals 3x plus 2y. When we plug in the coordinate 0, 2, our z value is 4. Z equals 3x plus 2y. At the coordinate 1, 0, our z value is 3. Z equals 3x plus 2y. Our z value is 8 at the coordinate 2, 1. Now, in the problem, we have been asked to find the maximum and the minimum, correct? Okay, so this is where we make a decision based on our objective quantity. What is the minimum value of z we found? 0. Okay, so we have a minimum of 0 at the coordinate 0, 0. Not really a surprise, right? But then what's our biggest value for z? 8. So we have a maximum of 8 at the coordinate 2, 1. Okay. Really, we have that one additional step of plugging it into the objective quantity, and by it I mean the vertices. We have one additional step of plugging our vertices into the objective quantity so we can make our decision. Okay? All right. Let's try this all the way from scratch. Okay? I have another just algebraic one that I want us to use to make a decision. Okay? I have a question. Does yours have an x is greater than or equal to 0? I want you to add in x is greater than or equal to 0. Can you do that for me? Okay. All right. So we need to graph these. X plus 2y equals 4. What is our y-intercept? What is our x-intercept? What is our x-intercept? Okay. Would we shade away or towards 0, 0? If we plug in 0, 0, does it satisfy? No, so we would be shading away, right? Okay. 3x plus y equals 7. Well, what's our y-intercept? 7. Okay? But our x-intercept is what? 7/3? Okay, so if that's one you want to change into y-intercept form, I don't think that would be a terrible decision. Okay, all you have to do is subtract 3x, right? That would be okay. All right, does 0, 0 satisfy that inequality? No, so we would shade away from that one as well. Okay. And then negative x plus 2y is less than or equal to 7. Let's see. Our x-intercept is negative 7. Interesting. And our y-intercept would be 7/2. Okay. Does 0, 0 satisfy that inequality? Ooh, it does, right? We get a shade towards it. And you know what? I've changed my mind. I wrote down the wrong. I want y is greater than or equal to 0. And y is greater than or equal to 0 means this right here, right? There's y equals 0. I really apologize for that one. Okay, so the blue and red line we're shading away from 0, 0. The green line we're shading towards 0, 0. So our shading is going to be here. And then we have that y equals 0 to worry about. Next, you have a question? Okay. How many vertex points do we have? I don't know about 2. I like 3. Okay, so we have one where green and blue intersect, right? Do you want to do algebra, or do you think we can do that without algebra? What does it look like? Okay, if it's 1, 4, is negative 1 plus 2 times 4 equal to 7? Yes. Is 3 times 1 plus 4 equal to 7? Okay, is 1, 4 our intersection? Check. All right. What else is an intersection?
It looks like 2, 1, 2, 1.
It looks like 2, 1. So this right here, the blue and red. So it looks like 2, 1. Let's be sure. And see, this is why I have my lines labeled. Is 2 plus 2 times 1 equal to 4. And then the blue line is 3 times 2 plus 1 equal to 7. Oh, good. So 2, 1 is an intersection. All right. What's another vertex point? Or is that it?
4, 0.
Okay. This 4, 0 right here is because we have this y equals 0, right? So we have this corner right here. And we know that's the case because we graphed that point, right? We know. Questions so far? Okay, take 1 minute and find me the z values for each of those 3. Don't make a decision, just find me the z values. Z equals 4x plus 2y. Z equals 4x plus 2y. Check with your neighbor. Okay, just shout them out for me. What's the z value at 1, 4?
12.
2, 1?
10.
And everybody together, 4, 0?
16.
Okay. So what's our minimum? So we have a minimum of 10 at the coordinates 2, 1. What's our maximum?
16.
Okay. Why not?
Well, because we don't have the vertex that traps it all in there. So
Oh. This goes on forever.
yes.
In what way? What direction?
Towards infinity.
So positive direction, right? These values keep getting bigger and bigger and bigger and bigger and bigger. Don't you think I could pick one out like up here? That would give us a z value that's bigger than 16. And we could pick another one bigger than that and another one bigger than that. So this is unbounded in the positive direction. So there is no maximum. Okay. All right, turn it over. This is where we really get into business. And I'll be very straightforward with you. On your test next Tuesday, the linear programming question that you will have to answer will look like what's on the back. It will be a word problem. Read through it. What are we working with? Well, I agree we're working with money. But what are the numbers we don't know? What are the quantities we don't know? How many what? Of each DVD player. So the first thing I want you to do is we're going to say X is the number of DVD player number 1. And Y is the number of DVD player number 2. Okay? So what's new in this linear programming is we're working with an optimization of some kind. Did you see a word maximum or minimum?
Yes.
Which word?
Maximize.
Maximize. And what are we trying to maximize? We are trying to maximize profit. So when we go to our objective quantity, we are trying to write an equation of whatever we're trying to optimize. So since we're trying to maximize profit, we want our objective quantity to be about profit. So I'm going to make it P for profit. If you want to use Z to be consistent with before, that's fine too. But it's going to be a different variable because we're talking about a third element here. Now, it's not like 3 dimensions. It's just I want to maximize profit. All right? Well, look in there. How much profit does DVD player number 1 yield? Okay, so $45 times the number that they have, plus how much profit does DVD player number 2 yield? 50. Okay, so we're going to write the objective quantity, and we'll come back to it once we have our vertex points. Okay? All right. is important. We have, is it constraints that I have for you next? Just want to be consistent with here. Our constraints. Okay, what did we talk about on, what day was that? Thursday? If we have tangible items, what do we have to write? Can we have negatives? Can we have negative DVD players? Okay, so X needs to be greater than or equal to 0. Y needs to be greater than or equal to 0. And do you see how I didn't really give you a graph here? Yes, you notice that? Okay. X is greater than or equal to 0. Y is greater than or equal to 0. I am only going to draw my first quadrant because that's all that matters in this problem. Because X is greater than or equal to 0 and Y is greater than or equal to 0. Okay. All right. We have more pieces of information, don't we?
Yeah.
Okay. We have information that, let's see, DVD player 1 costs $250. DVD player 2 costs $400. And do we have like a total amount that they want to stay under or above?
Yeah.
Okay, what is that total amount?
70,000.
$70,000. So when we take $250 times X plus, what did I say, 400? 400 times Y, they don't want to stock more than $70,000. So we want to make sure that when we take the number times the price, we are under $70,000. Okay. What other piece of information did they give us in there? Great. They don't want more than 250. So write down what inequality you think that would be. They don't want more than 250 DVD players on their shelf. Is that what you wrote down? X plus Y is less than or equal to 250. Excellent. Okay, so do you see why I didn't give you a graph? We have to graph Y, X plus Y equals 250. Okay, let's just make our own scale. All right, if we're going to have to graph X and Y intercepts of 250, what do you think we should count by?
50.
50s? Sure. Okay. So. Okay, so I'm going to graph this one in red. So are you in agreement that if I plug a 0 in for Y, our x-intercept is 250? If I plug a 0 in for x, our y-intercept is 250. If you need rulers, I have no problem with you using a ruler for this stuff. Which way would we shape? Towards or away from 0, 0? Towards. 0 plus 0 is definitely less than 250. Okay. So I'm just going to keep that in mind. I don't want things to get really busy up here, so I'm just going to try to remember that. Okay, in green, I'll make it all Christmassy up here. Okay, and this is where your calculator is going to probably have to help you, right? If I plug a 0 in for x, I have 400y equals 70,000. If we divide 70,000 by 400, what would our y-intercept be? 175. Wait. Uh-oh. So 150. was I thought it was counting by 25s. We're counting by 50s. Okay, we're good. What about our x-intercept? If we plug 0 in for y, what's 70,000 divided by 250? What? 280. So I'm going to label this 175, and you said 280. Okay, and are we shading towards or away from 0, 0 for that green one? Towards? Okay, so both of these are being shaded towards 0, 0, and we're restricted to the first quadrant because of x and y need to be greater than or equal to 0. So here is where we have shading. Okay, now, how accurate is that intersection point? That's not very accurate at all, is it? And my suggestion to you, I didn't pass out the rulers, and maybe I should have, but I would definitely advise you to use a straight edge of some kind when you do your homework this evening to just help you draw those lines straight, okay? And tomorrow when we do problems in class, I'll have you use a ruler. Okay? So how many vertex points do we have? I would agree. I think we have 4. So our vertex points, our vertices, okay, easy one, 0, 0. Okay, let's get the other easy ones. Okay, 0, 175, and do you see how I made a note that that was 175? Your x and y intercepts are going to potentially be a vertex, and so I would label them so you don't have to find them again, okay? All right, and what about over here? Okay, 250. 250, comma 0. 280 is not with the shading. Okay? Now our big task is to find this intersection point right here. How are we going to do that? A system of equations. And notice how he said equations. We have to make those equations. Okay? So I'm going to write 250x plus 400y equals 70,000. And then help me out. I'm going to go ahead and multiply that second equation, the red one, by negative 250. So I have negative 250x minus 250y equals negative 62,500. Is that right? Yeah. So I'm using elimination, right? If you want to use substitution, I'm going to get to the same place. I'm using elimination because I didn't want to rewrite things. All right? What happens? Our x's cancel. We get 150y equals 7,500 or something. So what does that make y? And if we know that one of our equations is x plus y equals 250, what's x? So that coordinate's not terrible. But I'm going to be very straightforward with you. You're going to have to use algebra on these. You're not going to be able to just guess and plug it in to check. Guess and check. Okay? All right. Remind me, because I forgot, what do we do at these vertices? Our objective quantity. Our objective quantity was P equals 25x plus 40y? 45x plus 50y.
Yes.
Okay. Okay, pods 1 and 2, plug in 0. Well, we can all plug in 0, 0. That was silly. Pods 1, 2, and 3, plug in 0, 175. Pods 5 and 6, plug in 250, 0. Pods 7 and 8, plug in 200, 50 for me. What's our profit at 0, 175? 8,750. Shake your head if you agree. Pods 1, 2, and 3. Okay. Someone from pod 5 or 6. What's our profit for 250, 0?
11,250.
Shake your head yes or no if you agree. Excellent. Pod 7, 8. 11,500. Shake your head if you agree. All right, so what's our decision? Okay. So 200 of DVD player number 1 and 50 of DVD player number 2 would give a maximum profit of $11,500. Okay, I understand. That took a little bit of time. You don't have very many in your homework. I also want to be very straightforward. Tomorrow in class, we're going to take some time and do a problem like in groups together. Okay? Your homework tomorrow will be another one. So, you have your homework, and look at your gold sheet. How many are required? Who has their gold sheet handy? 5. 5 are required. They're not all word problems. Some of them are like the ones on the front. Okay? Do your homework tonight. Understand that tomorrow you'll have one problem and a 10-minute video to watch for homework. You need to balance that out with making quiz corrections that are due Wednesday. So you have your assignment tonight, one word problem, and a 10-minute video to watch tomorrow. Figure out when you need to do quiz corrections. Figure out if you need to come visit me before or after school.